The comprehension you've seen so far read an existing list, but the list was never the point. Anything Python can loop over will drive a comprehension, and what comes out doesn't have to be a plain number. Each element can itself be a list, and once you know the shape, you can decode any comprehension you meet in 3 steps. Start with the middle of the comprehension, the part that supplies the values. In the last video, that source was an existing list. L, it doesn't have to be. When we talked about for loops, we said they iterate over integers following some pattern, range of 6 or range from 1 up to but not including 9, stepping by 2, which gives 1, 3, 5, and 7. That same rule applies here. As long as you have a sequence of values you can iterate over, you can plug it into a list comprehension. You can iterate over lists, over a tuple, over a range directly, over a range of the length of L when you want the index positions rather than the values. Whatever creates an iterable for you can go in the middle of a comprehension. Here is a comprehension driven by a range. The way to read it. I've got something I'm squaring, and the thing I'm squaring is each value in range of 6. So ask what the sequence of values is that I'm operating on. Range of 6 gives me 0, 1, 2, 3, 4, 5, 6 values, starting at 0, stopping before 6. And the thing I'm doing to them is squaring each one. So the list I get out contains 0 squared, 1 squared, 2 squared, 3 squared, 4 squared, and 5 squared. Evaluate those, and the result is 0, 1, 4, 9, 16, and 25. Now add a condition. Start with every element in the range. 0, 1, 2, 3, 4, 5, 6, 7. Range of 8 goes up to, but not including 8. The condition says E mod 2 is equal to 0, which is another way of saying the element is even. So I filter those 8 values down to the even ones, 0, 2, 4, and 6. Then I square every one of the survivors. The end result is a list containing 0 squared, 2 squared, 4 squared, and 6 squared. That is 0, 4, 16, and 36. Notice the order of operations. The range produces values, the condition throws some of them away, and only then does the expression run. So far, every element of the resulting list has been a single integer. We can do more. As long as you can write a little expression for the thing you want to calculate and add to the list, it can go in the comprehension, and that expression is allowed to build a list of its own. Look at the front of this one. It isn't E squared, it's a 2-element list, E and E squared, wrapped in its own square brackets. So each element of the resulting list is another list, and that inner list holds 2 things every time, the value being iterated over, and its square. Range of 4 gives me 0, 1, 2, 3, but the condition keeps only the odd ones, so the values I apply the expression to are 1 and 3, the 2 odd numbers in range of 4. The result therefore has exactly 2 elements, 1 paired with 1, because 1 squared is 1, and 3 paired with 9, because 3 squared is 9. One more consequence of the expression being arbitrary, it doesn't have to mention the loop variable at all. If you want a list of 100 zeros, there's no need to write a loop. Write in square brackets 0 for E in range of 100, and you have a list holding 100 zeros. The range is there purely to count out how many times the expression runs. It's a really nice way to create lists quickly. Now the payoff. Here's a comprehension that looks intimidating. The length of E. For E in a list holding the string XY, the string ABCD, the number 7, and the string 4.0, keeping only the elements whose type is equal to string. Work through it in 3 steps. Step 1. What are the values I'm iterating over? That's the list in the middle, the string XY, the string ABCD, the number 7, and the string 4.0. Look closely at that last one. It sits inside quotes, so it is a string of 3 characters, not the number 4.0. That distinction is the whole trick of this example. Step 2. From that list, which values am I actually keeping based on the condition? Only the ones whose type is string. Is XY a string? Yes. Is A, B, C, D? Yes. Is 7? No. 7 is an integer, so it gets thrown away. Is 4.0 is in quotes, so yes. 3 elements survive. Step 3. What expression am I applying to each survivor and what's the result? The expression at the front is the length function, so I take the length of each surviving string. XY has length 2, the string ABCD has length 4, and the string 4.0 has 3 characters, the 4, the dot, and the 0, so its length is 3. The result is the list 2, 4, 3. 2 questions come up here. First, why does this return a list rather than printing 2, 4, and 3 on separate lines? Because nothing is printing. There's no print call anywhere in the expression. When you write a list comprehension, you're telling Python to create a resulting list of values. That is all a comprehension does. The outer square brackets around the entire expression are what tell Python the thing you get back is a list. Second, does it support more than one condition? Yes. The condition sits at the end after the keyword if, and you can combine several tests there with and or with or, exactly as you would inside an ordinary if statement. Wrapping each individual test in parentheses is a safe habit. It makes the grouping explicit and stops operator precedence from surprising you. So the shape of a comprehension never changes. The middle is an iterable, a list, a tuple, a range, or a range of the length of a list. The front is an expression, which can be as simple as squaring a value or as elaborate as building a whole inner list. The end is an optional condition that decides which values ever reach the expression. And when you meet a comprehension you can read, ask those 3 questions in order. What am I iterating over? Which values survive the condition, and what expression is applied to each survivor? To practice what you just learned, this course has free exercises and AI graded feedback on ludium.ai. The link is in the description.